A table of values for the quadratic function g is shown. Here's a table of values here, okay? Which of the following statements about the graph of g are true, okay? Now I want us to look at the point 5, 5 and the point 9, 5. Look, the 5's there are the same, aren't they? So the vertex has to lie in between these 2 points. And we want to say, well, I know what the vertex is. It's 6, 8. See how it rises to 8 and goes back down to 5? So that's got to be the vertex. But you know what? That's not true. Look at your numbers 5 and 9. What number lies right in between 5 and 9? You would take the average of 5 and 9, wouldn't you? What's the average of 5 and 9? You have 5 plus 9, which is 14. You add the 2 numbers, you get 14 divided by 2 will give you the average of 5 and 9. It's not going to be 6 here, okay? 6 is not the 6, 8 is not the vertex. And right in between these 2 is 7. The vertex lies at 7, okay, when x is 7. So when x equals 7, we had our vertex, and by the way, that gives me my axis of symmetry, doesn't it? The axis of symmetry here is the same thing. It goes through the vertex. Okay, so the first statement's true. Now, what is this x equals 7? Well, let's see. There's 2, 4, 6, 8. So when x is 7, you're about right here. Draw a line straight up and down right there. This is called the axis of symmetry. All right? That's the axis of symmetry. Now, look at the point where x is 14. Let's see, there's 4, 8, 12, and 2 more makes 14. You're right there. That's 14, negative 40 lies about right here. So I've graphed this point now. Now, from 7 to 14, that's 7 units, isn't it? This is where x is 7, and here x is 14 right here. So that's 7 units. If you go back 7 units to the left, okay, this is the point 14, negative 40. If you go back 7 units this way, since this is the axis of symmetry, this point down here will correspond with this point down here. This thing will fold up along this line, and this point has a height or a y value of negative 40, and so does this point. You see where this point comes from? I went from 7, where x is 7, over to 14. That took me 7 units, didn't it? So if I count back 7 units this way, I'll be be back here at 0, won't I? So this is the point 0, negative 40. All right? So you have the point 14, 40, negative 40. You have the point 0, negative 40. And that's one of my choices. So that's a true statement. Now look where x is 10. Where is x 10? We have 2, 4, 6, 8, 10. And 10, 0 is an intercept right there. Now how far is 10 from 7? What's 10 minus 7? 3, isn't it? So I counted 3 points here. So I can go back 3 points this way from 7, 6, 5, 4. 7 minus 4 is 3. So this is going to be another intercept at 10, 0 and 7, 0. I mean 4, 0. 4, 0. See how this folds up along our axis of symmetry? Okay? So you have another point at 4, 0. Now, look at this point, 6, 8. That's what confused us a while ago. I wanted to say the vertex was 6, 8. That's right here, but the vertex is up here where x is 7. Okay? Because you're folding up along this line right here, and you're coming back down, coming back down. This is not going to be the vertex. Vertex is going to lie in here somewhere. Okay? Okay, your vertex is right here where x is 7. 7 minus 1 is 6. So if you come over here, 7 plus 1, you're going to have another point here. And your vertex is going to lie up there, isn't it? So the vertex is not going to be at 6, 8. It's going to be above that 8, isn't it? And it's going to be like 7 and like 9 or something like that. It won't be at 10. Well, it might be 10. It might be 7, 10. I don't know. Let me see. You have 2, 4. Let's count. 2, 4. Here it's 4, 6, 8, 10. I don't know. But it's above the 8. That's for sure. So there's your vertex. This is wrong. These 3 are a yes, and this one is a no. Okay? So you have yes for this, yes for this, yes for this, and no for this one.